Imagine staring into the deepest parts of the universe and seeing nothing. A void so immense, so empty, that it defies everything we know about cosmic structures. This is the impossible supervoid, an astronomical enigma that scientists still can't fully explain. Why is this vast region so devoid of galaxies? Could it challenge our understanding of the Big Bang? Or is it evidence of something even stranger? Stay with us as we dive into the mystery of the largest known void in the universe. Supervoids are enormous cosmic regions with far fewer galaxies than expected. While space might seem mostly empty, it's actually filled with clusters of galaxies, forming a web-like structure across the cosmos. But in some areas, gravity hasn't drawn much matter together, leaving behind vast cosmic deserts. The largest of these voids typically span hundreds of millions of light years. However, the impossible supervoid, also known as the Eridanus supervoid, is in a league of its own. Spanning nearly 1.8 billion light years, it's the biggest cosmic void ever discovered. That's a mind-boggling scale so large that it defies standard cosmological models. But why is this region so empty? And what does it mean for our understanding of the universe? One of the most puzzling aspects of the Eridanus supervoid is its link to the CMB cold spot, a mysterious, unusually cold region in the cosmic microwave background, CMB. The CMB is the afterglow of the Big Bang, a faint radiation spread across the universe. Most of it is relatively uniform, but scientists have detected strange anomalies areas that are inexplicably colder or hotter than expected. The Eridanus supervoid aligns almost perfectly with one of these cold regions. This has led some astronomers to believe that the void might be responsible for the temperature drop. The leading theory? The integrated Sachs-Wolf effect, a phenomenon where light from the CMB loses energy as it travels through a massive void. But here's the catch. This effect alone can't fully explain how cold the region is. So, is something else at play? If the Eridanus supervoid can't be fully explained by conventional physics, could it mean that our understanding of the universe is incomplete? Some researchers suggest that the void's shear scale challenges the lambda CDM model, the widely accepted framework for cosmic evolution. According to this model, the universe should have a fairly homogeneous distribution of matter with only minor variations. A void of this size is an extreme outlier. Some scientists believe this could indicate fluctuations in dark energy, the mysterious force driving the universe's accelerated expansion. Others argue that this void might hint at new physics, something beyond the Big Bang model. But the most controversial idea? Some have speculated that the supervoid might be evidence of a parallel universe, a collision between our reality and another, leaving behind a cosmic scar. Could this be proof that the multiverse exists? One of the strangest effects of the Eridanus supervoid is how it interacts with light. Normally, light traveling across the universe shifts slightly due to gravitational interactions. But the extreme emptiness of this region means that light behaves in an unusual way. Some observations suggest that photons passing through the supervoid experience unexpected distortions. Instead of behaving as predicted, the light appears to be affected by unknown forces. Some scientists propose that this could be due to exotic dark matter interactions, or even a new form of gravitational influence we don't yet understand. If this is true, it could redefine physics as we know it. Astronomers are still investigating this strange void. Future telescopes, like the James Webb Space Telescope, JWST, and Euclid Space Telescope, will give us more detailed images of the supervoid structure. By analyzing how galaxies behave near its edges, scientists hope to unlock more secrets about its formation. Some researchers are also studying other cold spots in the CMB to see if similar supervoids exist elsewhere. If they do, it might suggest that these voids aren't just random anomalies, but rather clues to a deeper cosmic mystery. Could they be relics from before the Big Bang? Or signals from hidden dimensions? Only time and advanced technology will tell. One intriguing hypothesis suggests that the Eridanus supervoid might be a remnant of dark energy dynamics. Dark energy is the mysterious force causing the universe to expand at an accelerating rate, but its nature remains unknown. Some physicists speculate that this void could be a region where dark energy behaves differently than expected, suppressing the formation of galaxies. If true, this would mean that dark energy is not uniform throughout the universe, but instead fluctuates in different regions. This could explain why some areas of space seem more empty than others. Some scientists even propose that the void is growing over time, pushing matter away from its center as dark energy repels normal matter. The challenge is that we don't yet have a way to directly observe dark energy. But upcoming telescopes, like the Nancy Grace Roman Space Telescope, will gather new data that might help test this theory. If the void's structure shows signs of expansion, it could provide groundbreaking evidence that dark energy is shaping the cosmos in unexpected ways. Some researchers think the Eridanus supervoid might be part of a larger cosmic structure, a giant bubble in the fabric of space. These so-called cosmic bubbles are thought to form due to quantum fluctuations in the early universe, which later expanded into massive voids. If the supervoid is part of a larger bubble-like formation, it might suggest that the universe has a more structured pattern of emptiness and clusters than we previously thought. Some cosmologists believe that voids and clusters could be linked in a cosmic lattice, where galaxies form in high-density regions, while voids remain almost empty. This idea could help explain why the void aligns with the cold spot in the CMB. It might not just be a random empty region, but part of a deeper cosmic pattern that we're only beginning to uncover. One of the strangest possibilities is that the supervoid might be a quantum remnant from the Big Bang. According to some theories, microscopic fluctuations in the early universe could have been stretched to enormous scales during cosmic inflation, creating regions of extreme emptiness. These quantum fluctuations might have led to some areas being denser and others being emptier, forming the cosmic web we see today. But if the Eridanus supervoid is the result of such an early fluctuation, it could mean that we're looking at one of the oldest structures in the universe, a fossil from the dawn of time itself. If this theory is correct, studying the void could provide insight into the very first moments of the universe, helping us understand how space-time evolved over billions of years. Could the supervoid be distorting time and gravity? Some astrophysicists believe that extremely empty regions like this one might affect the way gravity behaves. General relativity predicts that mass warps space-time. But what happens when there's almost no mass? Some models suggest that voids could slightly alter the passage of time, meaning that clocks might tick differently inside a supervoid than outside it. This is a small effect, but with precise enough instruments, we might be able to measure it. Additionally, some researchers propose that the void could act as a gravitational lens in reverse, slightly altering the path of light as it travels through. If proven, this could help refine our understanding of gravity on cosmic scales. One of the most radical ideas is that the supervoid might be evidence of a past collision between universes. According to some interpretations of string theory and the multiverse, our universe might be just one of many existing in a larger cosmic foam. If two universes collided in the past, it could have left behind a scar, a region where matter was disrupted, preventing galaxy formation. The Eridanus supervoid could be the cosmic fingerprint of such an event. If this were true, it would be one of the first pieces of observational evidence supporting the multiverse theory, fundamentally changing our understanding of reality. One of the most intriguing questions about the Eridanus supervoid is whether it's static or growing. In a universe that's expanding, some scientists theorize that voids might be expanding even faster than the surrounding cosmic structures. If this is true, it could mean that the supervoid is pushing galaxies further away, making it even emptier over time. This effect might be linked to dark energy, which is thought to drive cosmic expansion. Some models suggest that voids act as repellers, where the absence of mass causes nearby matter to accelerate away. Upcoming surveys, such as those conducted by the Vera C. Rubin Observatory, will track the motion of galaxies near the void's edge. If they are moving outward, it could confirm that this region is growing, providing key insights into the large-scale evolution of the cosmos. Some speculative theories suggest that the supervoid might not be just empty space. It could be a gateway to another reality. In certain models of quantum gravity and wormholes, extreme regions of space might connect different parts of the universe or even lead to other dimensions. If the supervoid contains unusual gravitational properties, it might be hiding an exotic structure like a cosmic tunnel or a region where physics behaves differently. While this idea remains highly speculative, studying the gravitational effects inside the void could reveal if something truly strange is happening. While no current evidence suggests the existence of such portals, it's an exciting possibility that keeps astronomers looking deeper into these vast cosmic mysteries. The universe isn't just randomly arranged. It follows a cosmic web structure where galaxies, clusters, and filaments form an intricate network. These structures are shaped by dark matter, gravity, and early cosmic evolution. The Eridanus supervoid is an anomaly in this web. While voids are common, one of this scale seems unusual. Could it be that this void formed due to an imbalance in dark matter distribution? Some simulations suggest that supervoids could result from collapsing cosmic filaments, where matter drained away, leaving behind an empty shell. If this is the case, studying the Eridanus supervoid could help us refine our models of how dark matter sculpts the universe. At first, the Eridanus supervoid seemed unique, but astronomers are now searching for similar voids elsewhere. If they find more of them, it could mean that these regions are a natural part of cosmic evolution. Recent sky surveys, like the Dark Energy Survey, DES, and the Sloan Digital Sky Survey, SDSS, have identified other large voids, though none quite as vast as the Eridanus supervoid. These discoveries suggest that voids may play a more significant role in shaping the universe than we previously thought. If supervoids turn out to be more common, they could hold clues about the nature of dark energy, cosmic expansion, and even the fundamental forces of the universe. With so few galaxies and stars, could life ever exist inside a supervoid? Most scientists believe that the conditions would be incredibly harsh. Galaxies inside the void would be much more isolated, meaning fewer heavy elements and fewer chances for planets like Earth to form. However, some astronomers speculate that advanced civilizations could thrive in isolated galaxies, adapting to extreme conditions. If intelligent life were to evolve inside a supervoid, it might develop completely different ways of harnessing energy, perhaps even tapping into dark matter or exotic cosmic forces. Could it be that alien civilizations inside a supervoid remain hidden from us simply because they evolved in a way we can't yet comprehend? Could time move differently inside a supervoid? Some theories suggest that in extremely low-density regions, time might pass at a slightly different rate due to the reduced gravitational influence. This concept is rooted in general relativity, which predicts that massive objects warp time. If a region lacks mass like the Eridanus supervoid, time might flow fractionally faster compared to denser parts of the universe. While this effect would be incredibly small, future observations might detect subtle differences in how light from inside the void behaves over cosmic time. If proven, it could provide new insights into the nature of space-time itself. Neutrinos are nearly massless particles that zip through the universe, barely interacting with normal matter. Some scientists believe they could play a role in the formation of supervoids. According to certain models, neutrinos could create large empty regions by smoothing out density fluctuations in the early universe. If neutrinos interact with dark matter in an unexpected way, they might have contributed to the extreme emptiness of the Eridanus supervoid. Ongoing experiments, like those at IceCube in Antarctica, are searching for high-energy neutrinos from cosmic sources. If we detect unusual neutrino activity near voids, it could hint at new physics beyond the standard model. The Eridanus supervoid isn't just empty space. It might also affect how radiation travels through the cosmos. Some astronomers believe that cosmic voids could act as filters, altering the properties of high-energy cosmic rays and background radiation. If the supervoid is large enough to influence radiation, it might explain some anomalies seen in ultra-high-energy cosmic rays, which sometimes behave unpredictably. By mapping how different wavelengths of light behave near the void, scientists could uncover hidden aspects of the universe's radiation environment. Dark matter is thought to be responsible for the formation of galaxies. But what if it's also responsible for cosmic voids? Some theories suggest that instead of an absence of matter, voids might actually contain unusual forms of dark matter that repel normal matter. If true, this could mean that the supervoid isn't completely empty. It might be filled with a mysterious, invisible substance that affects gravity in an unknown way. Upcoming missions, like the ESA's Euclid telescope, will map the universe's dark matter distribution in greater detail than ever before. If they find unexpected dark matter signatures inside the void, it could revolutionize our understanding of the cosmos. The Eridanus supervoid remains one of the most mysterious structures in the universe, but future technology may finally unlock its secrets. New telescopes, gravitational wave detectors, and deep space surveys will allow scientists to probe these vast, empty regions in ways never before possible. In the coming decades, we may finally determine whether the supervoid is a natural feature of cosmic evolution, an artifact of dark energy, or something even stranger. Could the Eridanus supervoid be the key to understanding the fundamental nature of the universe? Only time and science will tell. The Eridanus supervoid is the largest known void, but are there others like it? Astronomers are actively searching cosmic time. But what if the Eridanus supervoid is truly unique? That could mean it represents an extremely rare event, or even something beyond our current scientific models. Einstein's theory of general relativity tells us that gravity is caused by the bending of space-time. But what happens in a region where there's almost no gravity at all? Could the Eridanus supervoid behave like an anti-gravity zone? Some researchers theorized that voids could actually distort space-time in ways we don't yet fully understand. The absence of mass could create a kind of reverse lensing effect, where light passing through the void is subtly stretched or accelerated. If this effect can be measured, it could help us refine our models of gravity on the largest scales, possibly even hinting at modifications to general relativity itself. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove to push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.